Hello friends, I'm Sheshadri Naik from COEPian Academy, and we're going to look at the study circle problem that was recently circulated. The problem states that in a given triangle RST, we have drawn a line parallel to the base. The base is ST and the line drawn here parallel to the base, and it cuts the edges at P and Q respectively. So what we need to prove is that RP upon PS is equal to RQ upon ST. RP upon PS is equal to RQ upon QT. So that is what we need to prove. And to prove this, we are going to use two mathematical formulae and the theorems you can say. And let's see how it goes. Okay, so the two formulae or whatever, the two theorems are as follows. One is that we all know that area of a triangle is equal to 1/2 into B into H, the base and the height. So obviously, point number one is that if B and H both are same, if B and H both are same, the area will be equal, right? The area will be equal. The second one is that if H is the same, one of the two, say for example, H is the same, then the areas will be proportional to the base. So obviously these are very simple kind of statements which are based on the formula of the area. These are the ones which we're going to use. So let's get started with these particular rules being very clear. What we're going to do is we're going to do a small construction here. As you can see, the construction is done here, and here is that particular construction. So the construction is that draw the segments PT and PQ. So PT and PQ, and which is shown by the dotted line. So I have completed that particular thing. Now it forms various triangles, and we're going to look at the two triangles first, RPQ and SPQ. So RPQ and SPQ. So these are the two triangles which we're going to look at. Now, if I draw a perpendicular from the apex, it has a common point, which is Q. So if I draw a perpendicular from Q onto this side, the opposite side, which is RP or SP, the height is going to be the same for the two triangles. So obviously the areas of these two triangles, will be proportional to the bases. So area of RPQ upon area of SPQ is equal to RP upon PS. So it will be RP upon PS. So I hope this is clear. Similarly, now we will look at the other two triangles. Let me change the color so that it's clear. So RPQ and TPQ. So in this particular case, you see that RPQ is the common one. So RPQ is the common one, which we had taken earlier also. And the other one now I'm going to take is TPQ. Okay, so the other side of the triangle. So now what I'll do is, in order to decide the area, I will have to draw a perpendicular in the opposite direction. So I drop a perpendicular from P on to the opposite side, which is RQ or QT. It doesn't matter, it's going to be the same. So obviously this particular perpendicular is the same. So obviously in this particular case as well, the height is going to be the same. So the area of RPQ upon area of TPQ is going to be proportional to the bases. So the base here is RQ, the other one is QT. So the same formula or the same rule that we have applied, that if the height is the same, the area will be proportional to the basis. Now, what we do is you see that the two denominators are the same. So SPQ and TPQ. Okay, these two triangles will come to the same. The area of the two triangles will be the same. How? Let's see. So in case of triangles SPQ and TPQ, the base PQ is the same. So the base PQ, this particular thing, PQ, is the base for both the triangles, and they also have the same height since they are in the parallel lines, the two parallel lines. These two are the parallel lines, so the distance between parallel lines is the same. So for these two triangles, the base is the common and the height is the same because they are between the parallel lines. So therefore, we can make a statement that area of SPQ and area of TPQ. So what does this indicate? This indicates that the basis of the two statements became the same, the basis became the same, and the numerator is already the same, which is RPQ and RPQ. So the numerator was the same. Now the denominator also has become the same. So obviously we can make a statement. We can make a statement that since the LHS is equal to, so both the sides for both these particular equations, the LHS are the same. So the RHS can be equated. The RHS can be equated. So if you equate the RHS, what does it become? RP upon PS is equal to RQ upon QT. This is what we wanted to prove. So isn't it very simple? So remember that you need to use certain formulae or some theorems, and this particular proof becomes easy. If you like this particular video, please like it and subscribe our channel. Thank you for watching.